Good morning, everyone. I'm Syed Gauss, and this is my presentation on keyword decomposition using the Gram-Schmidt method. Keyword decomposition is a method in linear algebra where a matrix A is broken down into two matrices, Q an orthogonal matrix and R an upper triangular matrix, such that A equals to QR. The Gram-Schmidt process helps us to create orthogonal vectors from the columns of A. We do this by making each column orthogonal to the previous ones and then normalizing them to form. Then we use the inner products to calculate the values in matrix R. This technique is very useful in solving systems of equations, performing least square approximation, and ensuring numerical stability in computations. Now let's look into the Python program. This code takes a matrix, applies the Gram-Schmidt process, and produces two matrices, Q with orthogonal columns, R with upper triangular matrix. Together they satisfy the equation A equals to QR. So let's break down the code. So the first line, import numpy as NP, imports the numpy library which is used for numerical operations and matrix manipulations. Second line of the code defines a function keyword decomposition that takes a matrix A as input, N and M are the number of rows and columns of the matrix A. The third line of the code initializes two empty matrices Q, same shape as A, will store the orthogonal vectors R and upper triangular matrix to store coefficients. Then it iterates over each column I of matrix A. V is the current column vector we want to orthogonalize. Then further, this inner loop projects the current vector V onto each previous Q vector, subtracts the projections to make V orthogonal to the previous vectors. Then it normalizes the orthogonal vector V to make it a unit vector, stores it in the Q matrix. Then finally, it prints the final Q and R matrices. Then it takes a matrix input from the user like 1, 2, or 3, 4 and calls the keyword decomposition function with the user's matrix. Let's see the output. This is the output of the code. Thank you.